Okay, so I have 2 organic people here that should be listening to me. That whole table should be listening to me. You should be listening to me. Okay. I just want to show you guys where you're trying to work to when it comes to all the pages I've done for the SciPad. I just want to show you guys some of the questions that you get on the exam. So this here, I don't think I've actually ever put you onto this website, so let me do that. Okay. This is a website called No Brain Too Small. It is a really great resource to use. It has a lot of good summary notes and flashcards, but the thing that I love it most for is the fact that they go through all of the exams and they collate the questions. And when they collate the questions, they are grouping them based off of the ones that are similar to each other, so you can do lots and lots of practice of one type of question. I don't actually know if they're updating for the level 1 stuff because I'm very mindful that the standards are new. Let me just see. Science. I'm just curious to see. Yeah, they haven't. That's fine. There's still good stuff in there. Anyway, you guys, so unfortunately their level 1 stuff is the old unit standard, sorry, not the old unit standards, old standards, so the questions don't always necessarily apply. Because it may be still useful for you guys. I still do take some questions here. But for you guys, we are looking at level 2 chemistry, which is still not expired, so we can still use it. So they have a whole list of all the different standards and resources available. We are going to be clicking on this organic chemistry one, because that one is the one that you guys are doing. And there's lots of little things here. There's a checklist, there's like reminders, there's the essential study guide, there's notes. It's a really, really great resource. The main reason why I use it is to check the collated questions. So what they've done is they've themed all the questions for the past exam together, so that way you can practice that one over and over and over again if you're struggling with it. The one I want us to look at today is the naming and drawing questions. Just close that, and I'll close that. Nope, go away. Okay, so you can basically see how they've taken this naming and drawing question each year. Each year they should give you a table of stuff to name and draw. This one only goes up to a merit point usually. So keep that in mind. I think it's usually 3 out of 4 for the achieved and then 4 out of 4 for a merit if they're feeling generous. So it's not a whole lot of points, but it's a really important foundation when it comes to learning organic chemistry because we're going to have to communicate all the different things that are happening with it. So I will start with these 2 drawing ones because the drawing ones are easier than the naming ones. I'm mindful you guys have only gone up to the haloalkane pages, but you guys are pretty confident with the naming of branches and stuff. So I just want to show you guys some examples of how to name the different things just to kind of get you guys going. So that's why there's a lot of variety of pages that I've given you in this SciPad because they're all different functional groups that I want you just to get a touch on just so you know what they are like when it comes to the naming and the drawing and some of their properties. So first one we have here is butan-2-amine. So I'm going to write that on my piece of paper, and we're going to break down what that means. So butan-2-amine. So the whole idea of what we're doing now is we've learned the basic naming rules, and now we're trying to learn how to tack on the functional group naming. So first thing we're looking at is the parent chain and figuring out how long it is. So we see the word butan. So how many does that tell you? 4. So I'm going to draw 4 carbons down. 1, 2, 3, 4. Now we also see the number 2. So that tells me the location of something. I see at the end that it says amine. Now, I know you guys haven't gotten to these pages yet, but amine is one of our functional groups. Amines are NH2. So what that tells me is that on carbon number 2, I need to add an NH2. Like that. Then I just fill in the fill in the hydrogens. So hydrogens in this case, I check to see that carbon is bonded to one other carbon, so I need 3 hydrogens to fill it up. We're trying to get to 4. So CH3. This carbon has that and that carbon attached to it, so we just need a CH2. This carbon has 1, 2, and then the nitrogen attached to it, so that's 3, so I only need 1 hydrogen. And this last one only has 1 carbon, so that is 3. So that's how I translate the name to the drawing. So what we're learning is that there's all these different suffixes and prefixes that can tell us what we have functional group-wise. Amines are quite lucky in that they can both be named as a suffix and as a prefix. The other way we can name this is 2-aminobutane. That is the other option of how we name that, and that is also correct. So that's also a correct way to name this. Amino means the amine, 2 tells me it's on carbon number 2, and then butane tells me there's 4. So there's 2 different ways you can name that. Both are correct. Are we okay with that? All right, let me do the rest of the question so you guys can see it. Did I accidentally close it? Oh no, it's moved over here. Weird. Okay. I'm going to skip these 2 first because I want to do the drawing because I think the drawing's easier. So we have iodoethane. The best way to learn this is by practice. So again, you guys should be able to draw this because you guys have been doing these haloalkanes. So once again, I look for the parent chain and I see that it has ethane. So ethane tells me how many carbons? 2. 1, 2. Ido tells me the functional group. So I have an iodine. Now, which carbon do I have it on? There's no number attached to it. First one? No, it doesn't matter because if I attach it to this one, that's carbon number 1. If I attach it to this one, I'm just going to number it the other way around, so that's still carbon number 1. So it doesn't matter. And there's only one on there because it didn't say di or tri. And then I fill in the hydrogens. So this is going to be 2. So 1, 2, 3, 4. 1, 2, 3, 4. Okay? Let's go in the other direction now. So the other direction is we are now naming it based off of the drawing. So that has 1, 2, 3, 4, 5 carbons and an alcohol on carbon number 2. So 1, 2, 3, 4, 5, and then an alcohol on carbon number 2, and then all the hydrogens have been filled in that diagram. So I need to figure out how to name that guy. So first thing, we look for the parent chain, and that is the longest chain. What's the number? 5. So I'm going to go with what name? Pentane. So we're just going to do it pent, because we also need to be mindful that there's going to be a suffix attached to it. Pentane, I should say. And then we need to figure out the change in how we name it. So in this case, we have an OH. This OH is known as an alcohol. There's 2 different ways I can name the alcohol. I do need to specify what carbon it's on because it can be on multiple carbons. It can be on carbon 1, 2, or 3. This is on carbon 1, 2. I number it only once, and I want to give the functional group the lowest number possible now. So if I had a choice between a functional group and a branch, the number goes to the functional group. So 1, 2, so I would have 2 all. So the suffix ending for an alcohol is the OL. I could also name it with a prefix. Again, alcohols can do that. So it would be 2-hydroxyl pentane is another way you can name it. Cool. Make sense? So you got the foundation. We're just making it and building it up. Okay, the last one is a good one because it does have a branch and a functional group. So you see that there is 1, 2, 3, 4, 5, 6 carbons. There's a double bond, and then there's also a CH3. So let's draw this bad boy out. Like that. Go back to this guy. All right, so this is what I'm looking at. Again, like in all organic molecules, we're trying to find the longest chain. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So either way with how I number it, it's going to be the longest chain possible. All right. Next thing is I am mindful that I have 6. So if I was dealing with the number 6, what number should I be grabbing, or what name should I be grabbing? Hep is 7, hex is 6. All right, So I have 6, and then what else do I have? I have a methyl branch. So I need to indicate where that methyl branch is. If I was to number it, I would number it in this direction because it means that I can give the function group a lower number. If I numbered it that direction, the function group's going to have a high number. So I am very mindful. I'm just trying to figure out my new colors. So 1, 2. So I know I have a methyl on carbon number 2, and then I know I have a double bond here. The double bonds between carbon number 2 and 3, I give it the lower number, so I'm going to assign number 2 when I name it. So this is an alkene. So this would be 2-methyl hex 2-ene, because I'm trying to specify where it is. It's between carbon number 2 and 3. If I wrote 3-ene, then it would be between this carbon and that carbon. So when we're numbering it, we number it based on the lower of the pair. All right. So you guys have seen some examples. There's obviously a lot more. I'm mindful of the time. There's like a carboxylic acid here. This one has 2 functional groups. So you have to think about how you're going to name it with the 2 functional groups. That sort of stuff. So keep working on those practice questions from those SciPad pages to get an idea of how you're doing that naming. I'm guessing you guys maybe want one more lesson on it before moving on. Or how much are you guys going to do for homework? I'm basically stating, I think one more lesson's fair. Organic people. I think one more lesson's fair on this, but after that point, I want us to move on. We are going to be looking at some of the reactions for organic chemistry. Okay? That's why. Yes. So, organic chemistry people, be mindful that we are going to be moving on. All right? So, try to do some work over the weekend. Monday's the last day I want to work on this.